Okay.
In this class?
So, ladies and gentlemen, listen up, please. Okay, so I also have what I promised you. I promised you a study guide, and I have that for you. I will give that to you before you leave today. Okay? So, how you handle this review is totally up to you. Some of you may want to just listen, watch. Others of you may want to take copious notes. It's up to you, okay? How you handle this. So, alright, so as I said, we're not going to be doing any math today. You're not going to need your calculators, alright? We are simply going to look at as many different scenarios as I can think of, and we're just going to decide how we would solve the problem, okay? And I am, for the most part, going to go in chronological order, like order of topics that we learned them, okay? So we're going to start simply back in chapter 14, all right? And pretty much every question that I'm going to ask you is, like a sample question would be asking you to solve for the pH. And you're going to tell me how you would do that. So let's start right here. You're given 2 molar nitric acid. How do you find the pH?
Well, that's a strong acid.
You're right, it's a strong acid.
Its molarity is equal concentration of negative.
Okay. So this is also the molarity of H+. So what do you do?
Negative log.
Negative log of that number, solve, done. Okay? 6 molar lithium hydroxide.
Also strong.
Okay, it's a strong base. So what do you do?
Negative log of 6.0.
Okay, negative log of 6 will give you the POH 14 minus. Very good. Okay. 4 molar acetic acid. Okay. Okay, it's a weak acid. Okay. And guys, at this point, if you wanted to start listing out major species, you certainly could do that. A number of you saw immediately that it would be a Womack's problem. But let me explain how you could be sure about that. Those are the only 2 major species. That's it. So acid plus base, because water is the only thing in this list capable of being a base. And I brought this up before, but I want to make sure you all heard me. Because so many people keep saying, how do you know if a problem is a Newman or a Womack's? If water is one of the reactants that you chose, for example, in this list, water is the only thing that can act as a base. So my reaction is going to be acetic acid plus water. Since I chose water as one of my reactants, that's a Womack's. If water is one of your reactants, it's a Womack's. If you have a list of major species and you found acid and base and water is not one of your reactants, then it's a Newman. That's how you do it. Okay? So this would be, let me write it down. This would be nothing more than a Womack's problem. Let's keep moving. 3 molar ammonia, what is this? A weak base. It's a Womack's problem for the same reason as over here. The only 2 major species I have here are ammonia and water. Ammonia is the base, water is the only thing capable of acting as an acid. So, it's a Womack's problem. And you would get ammonium and OH minus. Okay? That's a Womex problem. Okay, great. Let's come back down here. 1 molar lithium fluoride. What is that, first of all?
Salt.
A salt, okay? Now, before we even think about a reaction or anything like that, let's imagine that this is a multiple choice situation, okay? You don't have a calculator, and you don't need one, because all I'm asking you is if lithium fluoride is dissolved in water, where will the pH fall? Like, what range? Acidic, neutral, basic? Okay, well let's review the thought process. Okay? The cation of a salt will potentially form some kind of base. What base could lithium form? LiOH, strong or weak?
Strong.
Okay, I'm gonna put a little S above it. The anion of a salt always forms some potential acid, HF, strong or weak?
Weak.
Okay. When you have a strong, weak combination of salt, what range will the pH be in? In the basic, okay? So if this are a multiple choice question, you are looking for an answer that is above 7. And there should be only one choice, okay? Now, let's fast forward to a free response situation. Now you're asked to actually calculate the pH of this salt. Okay, well, again, if you're ever unsure, list out your major species. Salts split apart. Okay? Pick an acid out of that list. Remember, an acid is something capable of donating a hydrogen. H2O is the only acid I could choose. Okay? And what is the only thing in that list capable of acting as a base? F minus. What type of problem is it? It's a Womex. Water was one of my reactants. Okay? Now, so this is going to turn into HF and OH minus, okay? Which here again is further proof that our final pH should be in the basic range, because OH minus is a product. Can you tell me, at the end of this Womex ice table, at the end of any Womex ice table, you always need some kind of equilibrium constant. Ka, Kb. Which kind in this particular example am I going to need? A Kb, all right? Yes. Because the thing being added to water is a base. It is accepting a hydrogen. Okay? Am I likely to give you a Kb? Probably not. Because I'm just that evil. That's more likely what I'm going to give you, the Ka for HF. Could you get the Kb that you need?
Yes.
Yes, of course. Okay? Great. Let's keep moving. 7 molar ammonium bromide. What is that? A salt, okay. I personally always find it helpful, if I know I've got a salt, to draw where anion and cation separate, okay. Ammonium, the cation forms a possible base. What base? NH3, strong or weak? Weak, okay. The anion forms a potential acid. What acid? HBr, strong or weak? Okay. So this is multiple choice, let's say. When I dissolve ammonium bromide in water, what kind of a pH am I going to see? Acidic. Somewhere below 7. Okay, great. Now, let's fast forward to free response. You're asked to actually calculate it now. I'm listing out my major species, okay? Ammonium ion, bromide ion, water. Which acid, what am I gonna choose as my acid in this situation?
Something that can.
NH4 plus.
Okay, NH4 plus is a stronger acid than water, so. What will be my base? Okay, if you're not sure, I mean H2O is the answer, but imagine if you put Br minus in this slot. That means your product is ammonium bromide. Why isn't that going to form? It's a salt,
Oh.
and what do salts do in water? They split. They don't stay together. It's a similar concept to that forming something strong. If you put Br minus in that position, your product would be ammonium bromide, and that's not going to happen because we just split it up. We're not going to put it back together. Okay? So what type of problem is this?
Wimix.
It's a Womix.
NH3 plus.
Okay? What kind of K value would you need at the end?
Ka.
A Ka, which I might give you. More likely, however, I would probably give you the Kb for ammonia. You could get it. Okay. Let me give you one more salt to look at. Potassium chloride.
7.
Strong, strong. That has a pH of 7. That is a neutral salt. Yes?
And with wheat, you compare the Ka to the Kb and find out which one's bigger, right?
Correct. Correct.
The K,
So if it was, yeah, thank you. If it was a weak combination, which this one isn't, but you would compare the Kb of whatever base this becomes to the Ka of whatever this becomes. If Ka is bigger than Kb, it's acidic, and vice versa.
Oh, it's the Kb value K and the Ka value is C. Yeah, that they would be.
That they would possibly become. Yes. Yes, Reed.
Could you for an example of what a weak would look like?
Sure. So a weak might be like that. Ammonium fluoride. Ammonia is the base, that's a weak base. HF would be the acid, weak acid. That's a weak combo. Okay? So what I would need to compare, guys, would be the Kb for ammonia
NH3 and HF.
and the Ka of HF. Okay? Now, I'm going to say something that is going to amaze you. That's it for chapter 14. We're done with chapter 14. I bet when you were in chapter 14,
This is like 20%.
Oh, yeah,
Right.
that's the zone like 20%.
but if in all honesty, guys, all chapter 14 taught you how to do was really one skill: how to do a Womix. Now we were going through it and you felt like, oh my gosh, this is so hard, but now that you've been through the hell of chapter 15,
True.
yes. Oh, thank you. Okay. He asked, what about percent dissociation? Thank you for reminding me, I was about to forget that. Okay,
I don't know what that means.
all right, well, let's review it then.
Oh, I know.
Let's say you were presented with this situation, this 4 molar acetic acid,
True.
and the question didn't ask solve for pH, but instead it said calculate the percent dissociation. Remember, sometimes that's called the percent ionization, they're the same thing. And you are going to solve it exactly the same way. Same reaction, it's still a Wommack's problem. Here's where the difference comes. Change color. Remember, percent dissociation is equal to whatever you solve for x. Remember, in a Wommack's problem, you find x by graphing it, divided by the original concentration, the initial concentration. So in this example, that would be 4 molar times 100. Okay? And sometimes, guys, they will give you, kind of ask you to solve a problem backwards. We did one in class where I gave you the percent dissociation, and that was your way to find x, and then you worked backwards from there. Okay, be aware that that does happen sometimes. Okay? Are we ready to move into chapter 15?
Yes.
All right. All right, here is our next situation. We have
Weak acid.
8 molar, listen, 8 molar nitrous acid
Nitrous.
and 2 molar sodium nitrite. Okay, let's take it piece by piece. What is that, this first part? A weak acid, and this is
Salt.
a salt that contains its conjugate base. Folks, this is by definition
A buffer.
a buffer system. Okay? Let me give you a piece of advice that will save you a great deal of time on our upcoming test and the AP exam. If you are presented with a problem where you are given more than one compound, before you start to write out your major species, because that's just what's kind of, you go on autopilot and that's just what you feel like you need to do immediately, before you do that, if you come across a problem that has 2 compounds, ask yourself the question, is it a buffer? Because if the answer is yes, what can you do right away? Hendy-Haas. You can do the Hendy-Haas equation. You don't need to list out your major species. You don't need to write a reaction. You don't need to do an ice table. Go straight to Hendy-Haas. Okay? I'm telling you that you can, and we did this in class, and you guys got really mad at me because I made you go through all this work when we could have just done Hendy-Haas. You could solve this with an ice table and a Wommack's problem, but it takes a lot longer. And I'm telling you, minutes are precious in a testing situation. You know that. I don't have to tell you that. So if it's a buffer, go right to Hendy-Haas and move on. If it's not a buffer, then start listing out your major species. Okay? All right? Here. Okay? Now, question.
Hendy-Haas's pH equals pKa plus log of base.
Negative log.
over.
No.
No. Okay.
Plus log of base over acid.
Everyone's like, no.
And
Okay.
it's always Ka. It's never Kb.
Correct. You don't have to memorize that equation, it's on your equation sheet. Okay, now, here's our next situation. Now folks, this first compound, CH3NH2, that's not something I would expect you to just look at and immediately know what it is. But what if, right next to this compound, you're given a Kb? What kind of a base? A weak base. Okay, great. So now you've got some more information. Weak base, what must this whole thing then be?
Salt.
A salt that contains
It's conjugate acid.
its conjugate acid. Okay? Is this a buffer? Yes. Which, save yourself the time, where can you go immediately? Hendy-Haas. Now be careful, because this one's not quite as straightforward as this earlier example. pH equals pKa. You've got a Kb. But you can get it, right? You can turn that into a Ka.
K divided mu over K equals K.
Okay. Hendy-Haas says pH equals pKa plus log of base over acid. Which one of these is the base? 2 molar or 5 molar? 2 base over conjugate acid, so I would 2 over 5. Okay?
And then would you do the negative log of the Ka, you get to get the pK? Okay, cool.
That's right.
We good?
Okay? Now, to every situation written in blue, I'm now going to start adding things to it.
Let's do it.
Or not.
I'm going to start adding things to each situation.
Oh. That's, thank you.
Okay? Guys, I can't stress enough what a good idea it is when you are reading a new problem. Every time you come across a compound, decide what it is first. Like even right above it, strong base. And HCl is a strong acid. Okay? It's 2 compounds. What's the first question you should ask yourself if you see 2 compounds? Is it a buffer?
Buffer system.
Is it?
No.
No. So what do you do next?
Titration. Major species?
Major species.
Oh, 2 for 2. This is where I get
Okay. You have 5 things to choose from. You're looking, always you're looking for an acid plus base. What's your acid?
A plus King Daddy.
Okay.
Water. Sand.
Did you choose water as one of your reactants?
Nah.
No, so this is a
Nitrate.
Newman.
Whatever it is.
It is a titration.
And yes, it is a titration.
I'm not wrong.
You're not wrong.
You're jumping the gun.
That's the goal. That's the goal, is just to not be wrong.
Okay, it's a Newman. So you set up an ice table. We're not solving anything today, guys, but I want to show you the 3 situations that you could be left with. All right? Situation number 1. You have a number left in this column and a 0 in that column. You're trying to find a pH. How are you going to do that? Okay, wait, first of all, what kind of numbers are going into this table? Moles or millimoles, your choice. So this is a number of moles or millimoles.
Yes. Then you have to divide that by total volume.
Thank you. You have to divide this by total volume,
Take the molarity.
negative log of that number, because it's just H+. Okay? What if you have this situation? Nothing left, 0, 0. pH is 7. What point is this called? This is the equivalence point, because the amount of acid and base would be the same number. Okay? What would you do if you had no H+, but you had some OH- left over? Divide by total volume, negative log it, POH. Okay. And a number of you, when you're going through the homework, have asked the question, how do I know if I need to use the total volume or an individual volume, like volume of just the acid or just the base? If you're at the initial level, then you're using, think of it as I standing for individual volumes. If you're at the end of your ice table, you always need to use total volume. Okay, moving on. Acetic acid and hydrochloric acid.
Weak acid, strong.
Okay, weak acid, strong acid. Is it a buffer? No. What do you do when you have two of the same kind of thing?
Oh, you take a stronger.
You take the stronger one, and what do you do to the other one?
Ignore it.
Ignore it. Okay, just to refresh your memory, how do you find the pH of a strong acid?
Negative log of its molarity.
Negative log of its molarity. Done. Okay? Ammonia, hydrochloric acid. Okay, hold on. Is it a buffer?
No.
No. So what should we do next? Sounds good? NH3, H plus, Cl minus, and water. Okay. H plus. Which base, what base am I gonna choose? NH3. Okay.
Wouldn't you have one?
No? Don't need to. Plus, it would be extraneous anyway, because water's, we always ignore it anyway. Okay. What kind of problem is this based on the fact that I did not choose water? It's a Newman, okay? This is a Newman, which means I need number of moles or millimoles. Again, we're not going to solve anything today, but we're going to look at our possible situations, all right? First possible situation. Under H plus, I have a 0. Under ammonia, I have a number, and under ammonium, I have a number. It's a buffer. And how do you solve for a pH of a buffer? Handy Haas. Okay. Where are you on a titration curve if not only do you have numbers left in this column and this column, but they're the same number?
Halfway.
No, halfway point. You're at the halfway point. If base and conjugate acid are equal, you're at the halfway point. And what's true about the pH at the halfway point? Equals pKa. Even if you didn't remember that, you would very quickly figure it out, because when you put, let's say, 5 and 5 into your Hendy-Haas equation, log of 1, 0. Okay? Here's our second scenario. Nothing in this column, nothing in this column. The only thing you have is NH4 plus. This is what you were talking about. First of all, if both of your reactants are completely gone, where are we in the titration? The equivalence point. Okay? How do you solve for the pH with this situation?
Switch it with a woman.
Okay? You take your reaction, reverse it, and do a Womix problem. Remember, guys, I told you equivalence point is the longest possible calculation.
Wait, can you say what you just said? Like,
Sure. If you have one product left over, 0, 0 here, and a number there, you're going to take this equation, flip it, and do a Womix problem underneath. Okay? Now, guys, it makes no difference to me, or to the AP exam, doesn't matter, if the next reaction that you write underneath it is literally just this one flipped, or this plus water and then predict your products, it's the same equation. It's the same reaction. It might look a little different, but it's the same reaction. Okay, last and third and final situation. H plus, NH4 plus. Is it a buffer? No.
No.
What are these two things that you're left with?
Acids.
Two acids. Two of the same type of thing. How do you handle that situation? Take the stronger one and ignore the other. Which one is stronger? H plus. Now, that's a number of moles. Divide by total volume. Very good. Okay, excellent. Okay, this is going to start to go a little faster because we're going to see the same situations over and over and over again. Two compounds. Buffer?
No.
Nope. Always a good idea to say, in words what these things are.
Salt.
Salt?
Strong acid.
Okay. Let's list out major species. H plus, Cl minus, Li plus, F minus, H2O. What do you want to choose as our acid?
H plus.
Okay? And F minus. What type of problem is this? It's a Newman. Okay? Well, I didn't choose water as one of my reactants. It's a Newman.
You
Okay?
didn't think Cl minus because then that was form of strong acid.
Correct. And folks, again, we're going to see the same three situations. What happens if you've got a number in this column and this column?
Buffer system.
It's a buffer. Handy Haas. What if you only have a number left in this column?
Reverse.
Reverse it. Okay?
Do it with-
And do a 1x. What if you have those two columns?
H plus. H plus.
H plus is a stronger acid than HF. Okay? You're going to see these same situations over and over and over and over. Okay? It's another salt plus a strong acid. Okay? Is it a buffer?
No.
No. All right, let's list it all out. H plus, Cl minus, ammonium ion, bromide ion. This one is a little bit tricky. What's the easy part? The acid's going to be,
H plus.
okay.
Plus water.
Why can't it be Cl? That would form a strong acid. Why can't it be Br? Same reason. Okay? So this is my only choice. We've never written a reaction like this. Okay? Technically speaking, this is what you would form.
What is going on?
And guys, this is not a Womex problem. This is a unique situation. This is what this is saying is the only thing that's going to contribute anything to the pH is that strong acid. This is not doing anything. Was either one of these part of this reaction? No. So how do you find the pH of a strong acid?
Take the negative log of its molar.
Negative log, that's it. Okay? Now things get really fun. We don't have two compounds, we have three. Now I will tell you This particular situation, you will not have to do any math with it. This is one of the things that's been taken off of the AP exam. Adding something to a buffer system and calculating it is no longer on the AP exam. However, you might be asked to come up with the reaction. You won't have to solve for anything, but you might be asked to come up with the reaction. So don't even ask yourself, is it a buffer? Because guys, a buffer only contains 2 things. This has 3. So what should we just do right off the bat? Major species. Okay, I've got HNO2. Why am I not splitting that up? Very good. Na plus, NO2 minus, H plus, Cl minus, H2O. All I want you to do is tell me what the reaction will be. Okay, H plus, that's the easy part. NO2 minus.
For that one, could the 3 possibilities be NO2 minus, Cl minus, and H2O?
Correct. Very good. Okay. Let's look at this buffer system. Ow.
Yeah, exactly.
All right. I'm listing them out. All right, H plus is the easy choice for the acid. Okay,
That's all you would do for that whole song?
correct, correct. In fact, guys, because that topic has been taken off the AP exam, my suspicion, because this is our first year, so I can't say for certainty, my suspicion is these kinds of questions would be in multiple choice only, okay? Because you're not doing any math. All you're trying to do is come up with the reaction, okay? Let us continue on.
Okay. Strong acid, strong base.
Is it a buffer?
No.
What do you do?
Major species.
Okay, fine.
Oh, it'd be H plus and then OH minus would give you water.
Very good.
You do stuff.
And you do stuff. Good. Okay? I'm not going to go through the situations because we've already done this one, but is this a Womix or a Newman?
Newman.
It's a Newman. Okay, great. Skipping that one, let's do this one.
Weak acid, strong.
Weak acid, strong base.
Not a buffer.
Not a buffer.
Titration.
It is a titration. Very good. Can you tell me, please, what my reaction will be?
H minus.
What's the acid?
HAC.
All right, HAC,
OH minus.
OH minus, gives us, okay. Womix or Newman?
Newman.
Newman. Again, and again, and again, and again, and again. The same 3 situations. What do you do?
Buffer.
Buffer,
Handy Haas.
Handy Haas.
Ooh, killed that.
What do you do?
Reverse.
Reverse it and do a Womix. What What do you do?
OH minus.
OH minus gets a stronger base.
Is it Alexa?
That's 2 bases, so you would go with the stronger one. Great. Let's see. Okay,
Yeah, it's a weak base.
weak base and a strong base.
Strong base,
Do the strong base, because it's strong.
and then ignore the other one.
Okay, and
then
ignore
take
the other one.
polarity, And then find the POA.
Yep, how do you find the pH of a strong base?
POH.
Negative log will give you the pOH.
Subtract that from.
Great, all right. Buffer?
No.
No.
Salt and aromatic base. Oh, wait,
OH minus.
What's the only thing that can be my my acid?
H2O.
Okay, and what's the base? Anybody want to tell me what the products would be?
OH minus and H2O.
OH minus and H2O. So,
That don't make sense.
what do you do here? What is this saying?
There's no reaction.
I mean, yeah, there is no reaction. What's the only thing contributing to the pH?
NaOH.
This is not participating at all. This salt is not doing anything. So how do you find the pH of NaOH?
Negative 14.
Just like what we did over there. Okay?
State
State.
puppy or something.
Yes.
And a strong base.
Buffer?
No.
Okay. Ammonium, bromide, Na+, OH minus, H2O.
OH minus and NH4.
Very good. Ammonium is my acid.
NH3 and H2.
Okay? For the billionth time. Okay, that's an exaggeration. What do you do? It's a handy Haas.
Reverse.
No.
Reverse and limits.
Charlie Brown.
OH minus stronger base, blah blah blah.
Very good. Very good.
I put.
KFC bagels.
KFC.
Oh.
So you're talking bagels.
That's big bagels.
I'm a huge
Okay.
fan of
Oh, yeah.
Ladies and gentlemen, to wrap up this section, you would not have to do math with this. Can you tell me, without me listing the major species up here, can you tell me what the reaction will be?
OH minus.
All right, OH minus, HNO2.
Yeah.
Oops, wait a
Good
minute.
one.
How did you do that?
I need to write out the species.
You must write up.
Okay, no math with that. Last one. Without me listing out the major species, you tell me what the reaction will be.
OH minus.
Okay, that's the easy part.
One of those C's.
One of them, well, it matters which
So-
one.
H3 and H2.
The top one.
Nope.
Bottom.
The
The
bottom.
bottom one.
What's wrong with what I've just written? Because I hear a lot of you saying this, and that would not be correct.
Plus.
Thank you. A lot of you I have seen on your homeworks are being very lazy about not writing charges. If the charges are not written, it's not correct. Okay? So just be aware of that. okay? Now, before we take a very short break, let me very quickly, let's look at this situation right here, okay? Weak acid, strong base.
I thought you said goldfish.
Ladies and gentlemen, if this is my situation, okay, where am I in my titration?
Equivalence point.
Okay, I'm at the equivalence point. Now, guys, in multiple choice especially, you will be asked questions like, it's titration between acetic acid and strong base NaOH will give you a pH at equivalence in what pH range? They're not asking you to calculate anything, but they're asking you to identify, just by looking at the nature of these reactants, where will the pH fall? In the basic range. Think about what you just said. Weak acid,
That was like positive.
strong base. It's gonna dominate,
Oh.
okay? Now, I'm gonna make up a number. Let's say you do the math, we're in free response now, and you find the pH to be, I don't know, 9.5. Okay, that makes sense, it's in the basic range, great. That's part A. Let's say that part B of this question gives you 3 indicators to choose from.
Oh, you did one.
You're given 3 indicators to choose from.
The Ka, that's the closest to the pH.
Hold on, hold
The
on.
exponent. The exponent is closest.
Oh.
It's the exponent of the. It's the exponent of the 10. That's it.
Okay,
We're calling it C.
3 different Kas. Now remember, this is free response. So you have to give a little bit more than just the answer. Okay? Part A, you found the pH to be 9.5. Okay? The next section gives you 3 indicators. It gives you the Kas of each one. What should you do first before you even answer the question? Okay, find the pKa, all right, of each one. Where is the useful range for an indicator?
One on either side.
pKa plus or minus 1, okay? Now, a lot of you have already figured this out. We did talk about this in class. The indicator whose Ka exponent is closest to our pH is going to be the answer. B is going to be the answer, all right? But I'm telling you, you're going to have to back up your answer. They're not just going to let you get away with saying, the answer is B because 10 is close to 9.5.
Oh, this wouldn't be like a multiple choice?
It could be, but let's say it's free response, where you have to give an explanation. Ladies and gentlemen, you would need to show, listen, you would need to show the useful ranges for each one of these, and here's the verbiage. Are you ready? The pH at equivalence falls within the useful range of indicator B.
Repeat, please. pH.
Repeat, please. Okay. The pH at equivalence falls within the useful range of indicator B.
Do I have to say anything about the Ka?
Nope.
Memorize it?
Okay.
That's an easy example.
So, question.
Would we be given problems that the useful range overlaps? Or
No. Good question. Would you ever be given a situation where you have 2 indicators where their useful ranges overlap? No. Okay? It's going to be very obvious which one to choose. And because this is an issue, listen to me, on this test especially, and on the AP exam. These free response questions have a lot of parts, A, B, C, D, E, okay? And a lot of times, you need the answer to part A in order to do the rest of the problem, okay? Let's say you have no clue, zero zippy clue how to do part A. You're supposed to find a pH and you don't know what to do at all. Are you gonna leave it blank? No. You need a pH value from part A to do the rest of the problem. If this is me and I'm doing this and I see these two reactants but I don't know how to solve for it, not only am I going to make up a number, like literally in this huge space on the paper, I'm just going to say pH equals, and come up with some number, but maybe I know enough that I know that it should be above 7. Again, maybe you don't, and even if you don't, just still make up a number. Even if your number is totally ludicrous, okay?
17.
Like pH equals 0.5. That's a silly answer, but whatever, okay? As long as you use that pH in the rest of your parts correctly, I'll go with you. You'll get full points for sections B through E.
Is that same on the AP exam?
Yes, it is. Yes, it is. Okay? Okay. The last section, which is very, very quick, there's not a whole lot on it, are the KSP problems. We're not solving anything, we're just going to set it up. You're given this. What does S stand for, by the way? Okay? You're asked to solve for the KSP. How do you how do you start any KSP problem?
Write the reaction.
Write the reaction. Okay, great. All right. Anybody see something missing? It's not balanced. Guys, we don't have to think about balancing in any other place except with KSP problems. And if you don't balance it, it's going to be wrong.
So 2 left.
Okay?
Oh, I can do these.
So, you're given the solubility for the entire compound.
Mm-hmm.
What is going to be the solubility for that ion?
S.
The same thing. Okay? What about the iodide ion?
2S squared.
No.
2S.
2.
Oh, we're not doing that. Okay, cool.
Okay? 2 times that solubility. Okay? Guys, I'm telling you that in a lot of these free response questions, part A is going to be write the expression, the equilibrium expression, which means no numbers. Okay? You will be asked to do that for acid-base problems as well. Okay? They're going to ask you to write the Ka expression, the Kb expression. What does my KSP expression look like?
PB.
All right, PB?
And
minus squared.
Okay. Now you can take these numbers and plug them in.
That's cute.
Okay? Quick, easy. All right.
Come on.
I'm gonna be like Proposal.
Never. He has broken feet, so it'd be hard to do anything. I think.
What do you do here? Wait. What's the first thing you should do?
Oh, there. We're doing a different problem. Awkward.
Write the equation.
Okay?
Is it assumed that the first one's a solid?
Yes, a KSP problem, the compound is a solid. All right? Thank you. Okay? Your you're being asked to find the solubility of that solid. If this is S, what's this one? 2S. And this one? S. Okay. My KSP expression is going to look like this. Plug in your S's. Solve. Okay. Come back to this one. You're not dissolving this in water. When we did this one first, we were dissolving it in water, even if they don't say it. I'm not dissolving it in water. Okay? I'm dissolving it in a beaker that already has something in it.
Oh,
Anything jump out at you?
yeah.
Yeah, the iodide ion is both in my salt and in the beaker I'm trying to put it in. Okay? We don't care about the solid before. Initially, before you put this solid in the beaker, is there any lead ion floating around in it?
No.
No. Is there any iodide ion floating in it?
Yes.
Yes.
3 molars.
Okay. What would you put here?
Plus
Plus S, plus 2S. You'd have to be given a KSP value. A KSP, which looked like this. That's going to get plugged in. That's going to get plugged in. Okay? Solve for S. You'd have to be given a KSP value. All right? Now, the very last thing that I'm going to say, the last type of problem that we looked at,
Of the Q, if it's greater.
it's quick.
Precipitate.
Yep, it's a precipitate question. You're given this information. 300 milliliters, 2 molar barium chloride is mixed with 100 milliliters, 6 molar lithium sulfate. And then you're given this number, some number for that. Okay? And the question says, will a precipitate form, yes or no? What are you going to do?
Oh,
Concentration.
yes.
Find the Q.
Okay, you've got to solve for Q. Remember, guys, Q is set up the exact same way as KSP. For which compound do I care about? The one that you're given the KSP for, barium sulfate. So it's going to look like this. Okay? Where am I getting these numbers? I can't just take barium 2 molar, I can't just plug that in there.
Oh, so you find the moles,
Okay, of barium, how do I find the moles of barium?
multiply by the 300 milliliters,
Okay,
and then you take those molars and then you divide by the total volume.
very good. Moles of barium over total volume. Do the same thing for sulfate. Okay, and let's just refresh our memories. Whoa.
Q is less than something. No.
If Q is less than KSP, okay. And guys, in one of my classes yesterday, we came up with a really stupid way to remember this,
Probably genius.
okay? If you imagine that this is like a beak, all right? This is like some animal that has a beak, okay? If Q is gonna eat KSP, nom, 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 there will be nothing left of him.
Oh, and then the big
Whereas here,
That's actually a really smart way.
he's still got a beak, but his beak is closed.
That's good.
He's not going to eat KSP, which means there will be something left,
KSP is a worm.
True.
okay?
What if it's
Oh,
at
it's
equilibrium?
KFC.
What if it's at equilibrium?
If these are equal, then it's at equilibrium. That's all you have to say.
That's it.
That's it. I swear, if somebody makes like Pac-Man noises, like during the test, that's gonna be hilarious. Okay? Ladies and gentlemen, that is it.